In this video, we are going to learn about the Lagrange multiplier. The method of Lagrange multiplier is a strategy for finding relative maximum value or minimum value of fxy subject to a constraint gxy equals to 0. There are 3 steps in this method. The first one is to state the Lagrange function fxy lambda equals to fxy plus lambda gxy, where fxy is the objective function and gxy is the constraint. The second step is to find the partial derivatives with respect to x, y, and lambda. The third step is to solve the simultaneous equations when all the partial derivatives are equals to 0. Maximum or minimum points is denoted as x0, y0, lambda. Maximize, minimize, maximum value or minimum value is equals to f of x0, y0. In example 1, we want to find the minimum point of fxy subject to the constraint x plus 2y equals to 24. Before we go to the first step, we have to rearrange the constraint so that the right hand side is equals to 0, then state the gxy which is equals to the left hand side of the equation. So now we can state the Lagrange function, and we must state whether we want to maximize or minimize the function based on the question. For this question, we want to minimize because we want to find the minimum point. So the Lagrange function fxy lambda equals to the objective function fxy plus lambda multiplied by the constraint gxy. Then multiply the lambda into the bracket. The second step is to find the partial derivative with respect to x, with respect to y, and with respect to lambda. The third step is to let all the partial derivative equals to 0, so we have 3 equations in terms of x, y, and lambda. For equation 1 and 2, always express lambda as the subject. To solve these equations, we will eliminate lambda first by equate equation 1 and 2, and we will get another equation in terms of x and y. Then substitute equation 4 into equation 3 to solve for the value of x. Then use substitution method to find the value of y and lambda. So the minimum point is 6, 9, negative 51. Example 2 is maximize the function fxy subject to the constraint x plus 2y equals to 22. So we have to rearrange the constraint first so that we can get the gxy. After that, we can start with the first step, which is to state the Lagrange function fxy lambda equals to the objective function plus lambda multiplied by the constraint. And we must also state the maximize before the Lagrange function. Then multiply the lambda into the bracket. Second step is to differentiate with respect to x, with respect to y, and with respect to lambda. The third step is to let all partial derivative equals to 0 to get 3 equations in terms of x, y, and lambda. Now to solve these 3 equations, we equate equation 1 and 2 to eliminate the lambda. Then substitute 4 into 3. We will get the value of 7. And then substitute y equals to 7 into equation 4 and equation 2 to find the value of x and lambda. Since we want to maximize the function, so we have to find the maximum value of the function by substitute the value of x and y into the objective function. After that, state the conclusion exactly as this one, where the maximum value is 74 when x equals to 8 and y equals to 7. This example is actually the same as the example from the previous video. The first thing we have to find here is the objective function. Since the question wants to maximize the monthly profit, so the objective function is the monthly profit. And we have learned how to find this monthly profit from the previous video. The second thing to find is the constraint. The constraint is from the word the production is restricted to a total of exactly 230 units. That means the total of x and y is equals to 230. Rearrange the equation so that we can state the gxy. So now we can state the Lagrange function. Now, the second step is to differentiate with respect to x, with respect to y, and with respect to lambda. After that, let all these partial derivative equals to 0 to get three equations in terms of x, y, and lambda. As usual, we will equate equation 1 and 2 to eliminate the lambda. Then substitute equation 4 into 3 to solve for the value of y. Then use substitution method to find the other two values. Since the question only want to find the quantity, so we can state the answer. Example 4 is find the two positive integers whose sum is 160 and the product has a maximum value. To solve this, we let the two positive integers be x and y. From the sentence, the product has a maximum value, we know that the objective function is the product of x and y, or the multiplication of x and y. From sum is 160, we know that the constraint is x plus y equals to 160. Rearrange the equation, then state the gxy. Now we can state the Lagrange function, then differentiate with respect to x, with respect to y, and with respect to lambda. After that, let all the partial derivative equals to 0. Then equate equation 1 and 2 to eliminate lambda. Then substitute equation 4 into 3 to solve for the value of x. And then substitute x equals to 80 to find the other two values. Then write the conclusion.